I think we are good to go. So yeah, thank you everybody for joining us. There's plenty of well-known faces, but also a lot of new faces this evening. So as a bit of an introduction, my name's Jennifer. I'm one of the co-founders of Build Manager and a passionate self-builder. I've got the other co-founders are on the call this evening, so that's Ben Taylor and Matthew Jones are with us as well. And for a little bit of background on Build Manager, for those of you that aren't aware of us, the company was founded by myself, Matt and Ben. And between us, we've got over 30 years experience in the property development industry, and we've all recently completed our own self-builds. Individually, we found the experience a real roller coaster. I've had a variety of challenges, so our intention is to share those as live case studies over the next few months. We actually joined forces in May this year because we shared a vision to create a platform that empowers self-builders to build their dream home just like we did. There's three ways that we help individuals. First of all, we offer free masterclasses, just like this one, on all aspects of self-building. We either deliver these in-house. Some of you might have been on our budgeting masterclass delivered by Ben, or we bring in industry experts such as Jo from NuHeat this evening. So if there's a specific topic that you'd like to learn more about, please do reach out. We get lots of suggestions and they're much appreciated. Secondly, we're working hard behind the scenes, onboarding industry-leading suppliers who are able to offer our members discounts. So as an example, we're now able to offer trade price discounts with Howdens. We've got 20% off all paints at Brewers, and we've got many more deals currently live. And in the next few weeks, we've got some very exciting announcements. So please do keep an eye out for that. And thirdly, we've got an online in-depth course that takes you and navigates you through the self-build process, right from the initial idea to finding a site to the pre-construction and onwards. So that takes you through the whole step. And you can either do that independently, or we are now offering a coaching option for people that would like some more hand-holding. So for anyone that would like to become a member today, we'll share the sign-up link in the chat so you can have a look at the different membership options and just see how we could help you. But tonight, I'm delighted to be sharing this space with Jo from NuHeat. NuHeat have got over 30 years experience in the underfloor heating and the air source heat pump sector. So she is definitely the right person to be delivering on this topic. Just to give you a little bit of understanding about the structure, Jo's going to deliver around 20 minutes, presentation of about 20 minutes, followed by a 30-minute Q&A, and we're aiming to wrap up at 8. If you've got any questions at all throughout the presentation, please just pop them in the chat, or at the end, you're welcome to come off mute and ask them yourselves. But yeah, I hope you enjoyed this evening, and I will hand over to Jo.
Thank you, Jennifer. Good evening, everybody. Thank you for giving up your Monday evening to come along and listen to me talk about underfloor heating and heat pumps. It's quite apt. I think the weather's turned a bit of a corner here, certainly. So it feels like we're kind of heading quickly towards heating season already. But so yeah, thank you. I'm going to talk tonight specifically about underfloor heating and heat pumps. So a little bit about new build kind of projects, as well as some renovation type of projects. We know quite often people are kind of extending quite significantly. So we're seeing underfloor heating coming in where we've got part existing build and part new build. Yeah, and then cover heat pumps. Going to talk a bit about how they work. They're not as complicated as sometimes they may seem at first glance. Cover a bit about air source heat pumps and ground source heat pumps. And a bit about the sort of installation and running costs on heat pumps. There's a lot of kind of misinformation out there about heat pumps, so hopefully I can give you all a bit more sort of detail about those and you know what's a good option for your project. And then, like Jennifer said, really happy to take any questions at the end of the presentation, so please do pop them in the chat as we go, and then Jennifer can fire them at me at the end, or happy to kind of take live questions when we get to the end of the presentation. So I'm going to start with a little bit about NuHeat. Jennifer obviously touched on how long we've been around. It was our 30th birthday last year, so we are at 31 years now. I've worked at NuHeat for the last, well, in 2 innings. So I originally joined in 2005, then I went away for a few years, came back. I now actually manage our new business team. So my team deal with self-builders like yourselves, as well as kind of new tradespeople. So we deal with all different types of customers. So yeah, self-builders, trades. So we deal with plumbers, plumbing and heating engineers. We deal with architects. We deal with contractors. And yeah, we are very much about bespoke designed systems. So underfloor heating and integrated renewables, so ground and air source heat pumps. We also offer solar thermal systems, so all kind of under that heating umbrella. At our core is we are all about customer service. So I think that's one of the key things that we are all about, is making sure that we're giving the best possible customer service to our customers that we work with. We've got over 80,000 systems installed in the UK, and that's sort of growing, growing all the time. And we're really, really proud of being the only company in our industry to have been awarded the Service Mark with distinction by the Institute of Customer Service. So yeah, that's a really great thing to shout about, I think, because it says how much we care. We are a design, supply and support company. So we don't install ourselves, but we do also have a network of registered installers around the UK. So for self-builders like yourselves, we can put you in touch with an installer in your area that we know, that we've worked with, that we've sort of been to visit and seen their installations, that we're really confident in. But equally, our systems have been designed so a competent DIY can install them. So we work with lots of self-builders that have installed or want to do a lot of the kind of practical install work themselves, and then maybe get a plumber involved to kind of do some of the sort of plumbing and install work to commission the systems for you. And we're really happy to support you in that way as well. Or if you've got great kind of trades on site, we can support those. So we offer lifetime technical support for our systems. So we're still supporting systems that went in over 20 years ago. You know, we'll get people call up that need a replacement thermostat or something for a system that's that old. So it's that lifetime technical support that is one of the things that really kind of gives us our market position. We are members of REC, so the Renewable Energy Consumer Code, and we also have our own MCS accreditation. So on the heat pump side of things, if that is something you're looking at, we'll support you through that whole journey. I'll talk a little bit later about the sort of MCS scheme and how that comes in on the renewable side of it. But certainly we can come out to site to commission ground and air source heat pumps and solar thermal systems if we're providing them, even if we're not kind of installing them, and then support you through things like the boiler upgrade scheme application process. We've got a great sort of in-house team that manage all of that for our customers as well. So that's a little bit about us and sort of how we work. I'm going to start with underfloor heating. Normally when I'm doing this in person, I'd always ask for a show of hand as to who's sort of doing new builds and who's doing renovations. And I'm going to assume everybody's interested in underfloor heating, and that's why you're here this evening. So a little bit about how underfloor heating works. So I don't know whether you've experienced it before, but it's a very different way of heating a room. So I think this is a really nice diagram that kind of gives you quite a good sort of indication of what we're doing when we're heating with underfloor heating. So comparing it to a radiator, the way a radiator is heating, you've got a small metal panel on a wall. Obviously, we're pushing heat into the room and we're creating convected currents of air. So the hottest place in the room when you're heating with a radiator is often up by the ceiling. With underfloor heating, it's a radiant heat source. So we've got your whole floor as our surface area. So it's a really comfortable, even heat, whereas we're heating the whole room uniformly. You're slightly warmer at your feet and slightly cooler at your head. So it's a very comfortable way of heating a room. You're also not creating those convected currents of air that a radiator system does. So you're not losing all your heat upwards. So it's very well suited to high ceilinged or vaulted areas. But also, I think, as this picture really shows, one of the really great things, because we're heating that whole floor area, is if you've got large open plan living spaces, which we're seeing a lot at the moment. So both in renovations and new builds, sort of large open plan living spaces are very popular at the moment. And it becomes very difficult in that kind of room with where you'd actually put a radiator, because you'll get a significant sort of temperature differential between where that radiator is and the other side of the room. Also, if you've got things like bifold doors that you're adding into a room, and then furniture placement, it does become very difficult with where you'd actually put your radiators. So underfloor heating is ideally suited to the type of projects that we're seeing are really, really sort of popular at the moment with these kind of open plan spaces. Aesthetically as well, obviously underfloor heating is designed to provide all of the heating to the room, so you won't need any radiators. at NuHeat and sort of other companies as well, one of the key things is the design side of things. So we're aiming to achieve 21 degrees in living areas and 18 degrees in bedrooms when it's -3 degrees outside. The room by room heat loss calcs and design that we'll do will actually confirm that we can achieve those temperatures. In a new build project, that's not going to be an issue. In a renovation, that's where things like the kind of insulation levels that you have in the property become really, really important. Because obviously, if you've got quite high heat losses, if you've got external walls that aren't insulated, those are going to have an effect on whether we can actually achieve the temperature that we want. However, bear in mind that would be the same if you were heating with radiators or underfloor heating. But what we do with the design that we're doing is make sure that we can achieve those temperatures. And if it does look like there's going to be any shortfall, tell you exactly what that shortfall is going to be. The philosophy behind underfloor heating is individually temperature controlled rooms or zones. So each room will have its own thermostat in it. That's obviously sensing whether there is a need for heat in that room. You can program rooms to run independently to each other. So if you've got guest bedrooms, you're not using that often, that you don't actually want kind of running all the time, or as you're running some of your living spaces that you are using all the time, you can program those rooms to run separately. That also allows for the fact that different rooms will have different warm-up times and different requirements. So you might have 2 rooms next to each other, exactly the same size. One of them's got 3 external walls and sort of bifold doors at one end. The other one's got 1 external wall and a small window. They're going to have very different kind of heating requirements, and that individual room control will allow for that, which is brilliant. Some of the options that we can look at then. So specifically, if I'm talking about a new build project, now any underfloor heating system. So I'm going to show you some of our kind of the kind of main ones now. But the warm water running through the pipework has got to be heating something up. So I think that's key. There's got to be a heat emitter that we're warming up with that warm water running through the pipework. Hopefully you've kind of got now, I'm talking about warm water underfloor heating. Electric underfloor heating is of course an alternative, but that tends to only be best suited for very small single areas. So if you were just heating a single small bathroom, for example, an electric mat is going to be a more cost-effective option from an install point of view. But anything sort of large areas or multiple rooms, actually having a warm water system is a much more cost-effective way of running a system. In fact, warm water underfloor heating running from a boiler is up to 25% more efficient than running radiators from a boiler, and actually running from a ground or air source heat pump, warm water underfloor heating is going to be up to 45% more efficient than running radiators. So you can see, you know, it is definitely kind of there's a sort of a cost-effective kind of running associated with underfloor heating as well. So this is a really traditional kind of screeded system, and a few years ago, this was, I think, certainly when NuHeat started out, this would have been one of the only options really of putting underfloor heating in. So for a new build property, what you're doing here is integrating your underfloor heating pipework within the screed. So on a ground floor sort of new build, assuming you're going for a sort of a concrete slab, you put your insulation on top of that to comply with your building regulations. And then the underfloor heating pipework is held in a track system. The warm water running through the pipework is then heating up your screed. So you can either go for a traditional sort of sand and cement screed system, or you can go for pumped liquid self-leveling screed. There's benefits with a liquid screed. It's denser, there's less air in it. It's a bit thinner in kind of the thickness that you need of it for it to be a structural layer. So you will definitely get sort of an improvement in the performance of a liquid screed compared to a hand-laid screed. Really great thermal store as well, because obviously that screed, once it's kind of warmed up, is going to hold that heat really well for you. Because underfloor heating is going to be running at a lower temperature than radiators, you will find it is a slower responding system. So from a control point of view, it's worth pointing out that it's more about maintaining the temperature in a room with a warm water system, rather than the sort of peaks and troughs you'd get with a radiator system, with that kind of on and then off during the day and then on again. With underfloor heating, it's more about maintaining the temperature, and that control that I mentioned, those thermostats, will support this as well. So with the thermostat in each room, you will have it programmed still to have your main kind of periods where you want that room at your desired temperature. So typically mornings and evenings, for example, 21 degrees. But what the control allows us to do is have a setback function built into the system. So if that room drops below a certain temperature during the day, it would just call for a little bit more heat to trickle in to maintain that temperature. You can imagine kind of heating a sort of thickish layer of screed up. So for a hand mixed screed, you'd be looking at a 65 mil layer. To heat that up from cold, you're going to be talking a few hours. To heat that up from kind of this setback function, you're going to be looking at a much more kind of controllable system. So it's worth bearing that in mind when you're thinking about kind of what underfloor heating system you go for and how you're going to be controlling it. One of the myths with underfloor heating, I think that we hear all the time, certainly my team kind of often come up against it, is that people don't think they can put underfloor heating on upper floors between joists, especially if people if thinking they're using carpet up there. I'm going to come on to floor finishes a little bit later, but there are some really great systems to install underfloor heating up on a first floor in between joists. And this is our clipper plate system. So this system allows you to install from below up between the joists once that floor deck's down. This is a really great system if you are using a timber frame build. So as part of the structural integrity of a timber frame, that timber frame manufacturer will have to get that floor deck down. So they will usually rock up on site, put your timber frame up, put that structural floor deck down. They will then leave for you to come in and put in all your kind of sort of get your contractors in to do your further works. This system is brilliant because it's a preformed aluminium tray that attaches to the underside of the decking above from below. Also works very well if you're using some of the more modern types of joists, so the kind of I-beam joist or the posi joist or the web joist, sometimes they're called, with sort of the metal strutting, which actually gives you then the gaps to pass the tubing between the bays. In this system, it's that metal tray then that we're warming up with the warm water running through the pipework to heat your rooms above. Really great system for new builds, and it's a completely dry installation, so no wet sort of screeds or anything going on upstairs. This is another one which is a really popular one. We've just recently launched this. There are other similar ones out there, so you may well have kind of looked into it. And this is actually turning your structural floor deck over joist into your underfloor heating kind of zone. So this uses a pre-routed chipboard with a sort of a foil facing on it that the pipework sits in those pre-routed channels, and those are going directly over your that routed chipboard is going directly over your open joists. So this becomes your structural floor deck rather than putting a standard 22mm chip or ply deck. You put this 22mm routed chipboard. The pipework then sits in those pre-routed channels, and then you've got a 6mm cover board that goes over the top of that, which you can see from this picture is really clearly marked, so you can see where the pipe runs are underneath for fixing that board down. So it is a little bit thicker, so it would be a 28mm build up rather than a standard 22mm chipboard, but the underfloor heating is then incorporated into that floor deck. So this is a really great system for renovation projects, or or for new builds as well, allowing you to actually turn your structural floor deck into your underfloor heating zone. Those boards there, it says they're sort of bi-directional, so it will allow for joist changes in direction as well. But we would, any system that I'm talking about tonight, I think the really key thing to remember is that whoever you work with on the underfloor heating side of things, the design side of things is what's going to really kind of give you that peace of mind, and that system's been designed for your property with all of the kind of nuances and things that come up in your own kind of project have all been factored in at that sort of key design stage there. I am going to talk a little bit about renovation systems. I think it's important to consider that quite often, certainly with kind of extension projects and things, some of you may have renovation projects in mind. A few years ago, it was certainly when I joined NuHeat, actually back in 2005, there wasn't really anything on the market for renovations without having to go down the route of digging up an existing concrete floor. So it became very difficult to accommodate underfloor heating into existing properties without a whole lot of work to kind of get that house ready for underfloor heating. What NuHeat have launched, and there's now a number of them out on the market, is some really nice, high-performing, responsive, low-profile systems that actually allow you to get underfloor heating in with minimal height build-up. You can actually kind of install it around, as is shown in this picture here. You can install it around an existing room. People have put some of these low-profile systems around existing sort of kitchen units and things as well. So yeah, we've got systems as low as 15mm. That can actually kind of go directly over an existing concrete floor. Now, the reason we can go directly over an existing concrete floor, even if that's not insulated, is because as long as that concrete is down to ground, because the ground temperature below sits fairly static year round at about 12 degrees, we're only on average dealing with about a 6% downwards heat loss. So actually putting a really responsive, high-performing system on top of that allows us to kind of swallow that slight downwards heat loss, but still be able to get a really good heat into those rooms above. So Low Pro 10 is the thinnest one that we do. So this is just 15 millimeters thick. So this is using a pre-routed fibre gypsum board. Now, it's very important to say this picture is obviously showing that going over suspended timber joists. If you are looking to put this over a joisted floor on the ground floor, the downwards heat loss with a vented space below jumps up from that 6% I mentioned before, if it's solid down to ground, to about 45%. So if we're talking about a ground floor with suspended timber joist with a vented space below, insulation is absolutely key there, because we don't want to lose all that heat down. So in a renovation where you've got ground floor with suspended timber joist, you would absolutely need to insulate in between the joists before you put a sort of an underfloor heating system down over the top of a structural floor deck. But this one is 15 mil. It's a pre-routed fibre gypsum board. It's a fantastic product. It's won awards, this one. The pipework sits in those pre-routed channels, and then that's what we're warming up with, the warm water running through the pipework. So it can't sit directly on a layer of insulation. It in itself isn't structural, so it does need to sit on a rigid structural deck. If you were putting some insulation down, you'd need to then put a structural deck over that insulation before you could put the low profile system down, or use something with a very high compressive strength that we can go directly on top of. We can always advise you on that, or sort of whichever system you're looking at using will be able to give you that information. But brilliant system, really quick to install. Our other kind of key low profile one is our Low Pro Max system. Again, this if you can see me, I've got this in my background. I'm not actually sort of on a giant piece of castellated panel, but that's what it looks like. So and this is by far, actually, is, if you ask anybody in my team what product they speak the most about, they will say Low Pro Max. So it's a 22 millimeter complete build up. It's a preformed castellated panel. People talk about this like it's looks a bit like an upside down egg box. So these panels come in big sheets. I'm told the glue on the adhesive on the back of them is so strong that if you stuck it to a wall, you'd be able to climb up it. I haven't tried it myself, but I'm told that that can work. So it's got a peel off adhesive layer on the back. So you'd cover your floor with the panel that holds the pipework. It's then a latex self-leveling compound. Some of the companies do similar systems where they don't provide the leveling compound. So I would really recommend, if you are looking at this type of system, that you really understand what's being supplied by your underfloor supplier. That leveling compound, you can walk on it after about 8 hours, and it's fully cured after 72 hours. So final floor finishes can go down on this after 72 hours, and it gives you a really nice kind of mirror finish, this one. So it's great for either like a resin topper or things like Cardine and Antico type finishes, which again, we're seeing more and more people using in their projects. So really nice system. Now, the two, just to kind of give you an idea about why we might go for one over the other, Low Pro Max is a slightly higher heat output system, a quicker responding system. So this would certainly be our go-to on renovations where the insulation levels maybe weren't so great, but also if renewables are coming into play. So underfloor heating running from a boiler, we're typically looking at a flow temperature of about 50 to 55 degrees through the underfloor heating pipework. If we're running from a heat pump, we're looking at more like 40 to 45 degrees. Now, if you compare that to the temperature that a radiator would be, so a radiator running from a boiler, you're typically going to have water running through that radiator of about 70 to 80 degrees. The new building regs that have just come into play are pushing people down low temperature systems, which really makes underfloor heating a great option, because you can imagine if you've got a lower temperature water running through a radiator, you're going to have to compensate in the size of specification of those radiators. So look at either much larger surface area radiators or high performance fan assisted type radiators that have been designed to work with lower temperatures. So actually underfloor heating is a really great choice, not just for if you're using renewables and we've got a lower flow temperature from our heat source, but also if you've got to go down this route now of having a low temperature heating system, which is what the new Partel regs are pushing people down for new build projects. So yeah, so that is Low Pro Max. Now this is, I always love this slide because people often ask at shows and, you know, speak to my team, and they think they can't have underfloor heating if they want to have a carpet, and you absolutely can. You can pretty much use most floor finishes with underfloor heating. There are just a few rules to go by. So carpets are absolutely doable, but what you can't do is have a big, thick, deep carpet, because that's going to act as an insulating layer and prevent that heat getting through. who knew that carpets have TOG ratings like duvets? So much like a duvet, if you speak with your carpet manufacturer, they'll be able to tell you what the TOG rating of their carpet is. If you're using an underfloor heating system, if you're using a boiler, then your carpet and underlay combined should have a TOG rating of no higher than 2.5. If you're using a heat pump and that lower flow temperature that I mentioned, your carpet and underlay should have a TOG rating of no higher than 1.5. It's also worth bearing that in mind if you're thinking about having a hard floor finish like a tile or an engineered board, and you're wanting to put rugs down on top, because again, that rug, you wouldn't want a big thick deep rug because that's going to act as an insulating layer to prevent that heat getting through. On a sliding scale, a natural stone or tile is always going to be your best option with underfloor heating. It's also going to add to that thermal mass. It's going to feel warm to the touch. So you are going to kind of get the better sort of performance heat output wise with that kind of floor finish. But you absolutely can use woods. As shown on this picture here, we'd recommend an engineered board rather than a solid timber board. It's not going to have the moisture content that a solid timber board can, which can potentially, if you imagine putting a sort of a wood that's got a high moisture content with warmth underneath it, it could potentially kind of warp and crack those boards, which you don't want. So an engineered board is your best option with underfloor heating. You can use laminates. You can use things like LVT, Carndean and Amtico, very popular at the moment. But both those and engineered boards are actually classed as sensitive floor coverings. So it's really important, again, this is where that design side of things comes into play, that at the design stage, one of the things we'll want to confirm is what floor finishes are you using in each of the rooms. And that's because some floor finishes require that we limit the floor temperature a little bit. So British standards allow us to take the floor temperature up to 29 degrees. Some floor finishes, we have to limit that to 27. So engineered boards, Carndean and Amtico, we have to limit that to 27. So what we do in those areas where we know that floor finish is being used is, as well as having the room thermostat on the wall, we'll also have a floor sensor, so we can just keep an eye on that floor temperature and make sure it's not going to damage your sort of nice expensive floor that you've put down. So that's always factored in at the design stage. So yeah, so that is my whistle stop tour of underfloor heating. And now I'm going to come on to heat pumps. Now, as I mentioned, because of sort of people going down the sort of low temperature route or having to go down the low temperature route, heat pumps are becoming much, much more prevalent and much, much more popular. It's worth mentioning that about 90% of installs of heat pump installations in the UK at the moment are air source units rather than ground source. There's a few reasons for that I'll come on to talk about. I think what's absolutely critical if you're thinking about going down the heat pump route for your project is that you make sure that whoever you're speaking to is really understanding your project, because heat pumps are brilliant in the right situation, and that's not every situation. There are really key things to consider with a heat pump, because it's a low temperature system, and it's got to be right for your project. It's got to be a viable option to make sure it's going to work for you, really, more than anything. So this slide's nice. It just kind of gives you an idea about how a heat pump works. Often people will talk about heat pumps as reverse fridges, basically, but essentially what we've got is a heat pump is harvesting heat. So we're harvesting a low grade energy either from the air or from the ground, whether that's with a borehole option or with ground loops with sort of a glycol antifreeze mix running through them. So it's stored solar energy from the ground or from the air. And we're putting that low grade energy into a refrigerant, which is obviously a gas. You compress a gas, it gets hotter. So basically we're taking a low grade energy, putting it into a refrigerant cycle, we're compressing that, which makes it hotter, and that gives us a higher grade energy to heat your primary side. So as I mentioned, underfloor heating running from or radiators actually running from a heat pump will typically have a flow temperature of about 40 to 45 degrees. But we'll also get your domestic hot water quite happily up to 50 degrees. Most people have their baths and showers at around about 36 degrees. So 50 degrees is more than ample for what you're going to need for your domestic requirements. 50 degrees coming out your tap would actually scald you. So you would never want your water that hot coming out from your tap. What you'll also find is that any sort of setup like this, we have to build in things like a Legionella purge. So the system's always programmed to take that domestic hot water cylinder up to 60 degrees regularly to do a Legionella purge. That's all built into the design of the system. So just coming back to this cycle, once you've taken that heat out of that refrigerant, it goes back into an expansion valve, and then that cycle starts again. So that's essentially what's going on inside a heat pump. Air source or ground source. So both options are great. The tipping point tends to be once you get over about a 300 square metre house, it can be a bit more cost effective to go for a ground source. But you do need, as I'll come on to, if you're going for the kind of ground loop array, you need quite a large area of clear ground to kind of collect that stored solar energy. Or you can go down the borehole route, which is much more expensive, still very efficient, but much more expensive because you've got the cost of then getting a specialist drilling contractor involved to actually kind of drill down and sort of and install the borehole side of things for a heat pump. So I'm going to talk first about air source heat pumps. As I said, these are by far the most kind of common route in the UK. We talk about the efficiency of a heat pump in terms of what's called the COP. So that's the coefficient of performance. I've just noticed my name's gone back to David Roberts, hasn't it? I didn't rechange it. There you go. I'm not David Roberts, people. I haven't come back as a different person. Right. Sorry, that's made me giggle. So air source heat pumps. So we talk about COP, which is the coefficient of performance. And then you'll also hear people mention SCOP, which is the seasonal coefficient of performance. Essentially, that number is how many kilowatts of heat we're getting out from the unit for every 1 kilowatt of electricity it's taking to run the unit. So the heat pump has an electrical requirement to run the compressor and so on. But then we're getting, because we're, like I said, we're harvesting that heat, low grade to high grade, we're getting more heat out than electricity we're putting in. So that's why we talk about them being 300% efficient or more. That's based on that COP figure. Now, one of the things I would really encourage you to do if you're looking at an air source unit is to understand the seasonal performance figures for the unit that you're looking at, because it's not just about the kind of optimum factory conditions. So often people will say their COP is super high, but that might be only when it's producing water at a 35-degree temperature and it's 7 degrees outside, which, as we all know, isn't most of the heating season in the UK. So actually, it's really important to understand how your unit, or the unit that you're considering, is going to perform when it's sort of -1, -2, -3 degrees outside. At NuHeat, we always size our heat pumps to provide over 100% of the load when it's -3 degrees outside. So that's all of your space heating and domestic hot water when it's -3 degrees outside. They will still work down into lower temperatures, but they are having to work harder. So with an air source unit especially, that COP figure will fluctuate a lot more than a ground source, because the air temperature fluctuates a lot more than the ground temperature does, which is much more static year round. So with an air source heat pump, actually that COP figure you would expect to be lower in the winter, and that's why it's also very important, to be honest with you, that a heat pump isn't, if you're looking at a heat pump to replace a boiler, it's not going to slash your bills in half. That's not going to save you thousands of pounds every year on your running costs, because they are still, you know, there's still a cost against them. And at the moment, if you look at the price, which I'll come on, I've got another slide in a moment, but you will see the cost of electricity per kilowatt hour at the moment is still quite high. So actually, when you compare it sometimes to things like mains gas as an option, you will find the running cost of an air source unit compared to mains gas is still fairly comparable at the moment. But of course, we don't know what's going to happen with the prices of things like mains gas. We know the government are looking to move away from mains gas, so they want no new mains gas boilers going in over the next few years. So yeah, you would expect that to kind of start to play out a little bit in the price of sort of running costs of electricity and things, and especially as we've got more green ways of producing electricity. So an air source heat pump, anyway, so you've got your unit outside. Inside you'd have a buffer tank and your domestic hot water cylinder. A heat pump is going to be very quiet. That's the other thing I think with an air source unit, is that people look at these and they think they're going to be like a big industrial air conditioning unit that you see on the side of factories, but actually these are designed to sit outside domestic houses. They are very quiet when they're running. They've been designed to kind of not impact massively on your lives. But yes, there is a noise associated with them. And that's why actually where you locate that heat pump has to be factored in with an air source unit. Things like neighbours' boundaries, neighbours' habitable windows all need to be factored in. And there's certain calculations that you need to do to get through and sort of tick all the boxes to actually be able to position an air source unit outside your property. We would always advise on that as we go. Typically a single unit, a single air source unit, will come under permitted development, but if you get up into the realms of needing 2 units, or if you're in an area of outstanding natural beauty, if you wanted to locate it facing a highway, then you will need full planning permission to locate an air source unit on your project. So there's certain things to kind of factor in on that, but we will always be able to advise you on that as you go. Ground source units are much more consistent from a performance point of view throughout the year, because that ground temperature is much more static. To give you an idea about the kind of area that you're going to need, so if you went for the ground loop array, so that's the pipework, horizontal pipework laid out across your land, then you are going to need you're going to need 2.5 to 3 times the footprint of the area that you're looking to heat. So that's the total square meterage of your house. If you've got a 200 square meter house, you're going to need up to 600 square meters of clear ground. So that's not ground that you're going to plant trees on. It's got to be clear ground. If you imagine the ground like a battery charged up by the sun, we need to be also away from sort of trees and root systems and things as well. So you do need a big old plot if you're going to have the kind of ground loop array in, or you can go down the borehole route and get sort of specialist drilling contractors involved on that side of things. Typically for a borehole, we'd normally expect you to need about 0.9 meters of borehole depth for every 1 square meter of kind of heated area in the property. So that gives you a rough idea about what you'd be looking at, sort of borehole depth requirements. With the ground source unit, you've got the ground source unit itself, which would be housed inside along with your buffer tank and your domestic hot water cylinder. Again, the kind of plant room side of things is something that your supplier will always be able to advise you on, so you can factor that in. A big consideration, I think, is that there is more to accommodate than a traditional boiler system. So you've got to think about plant space. In a new build property, you've generally got the luxury of being able to design that area in, but you do need to be able to kind of accommodate the plant that is a bit more to accommodate than a boiler. There's pipe work and things. But again, we'll always kind of advise you on that, and would sort of support you on the sort of dimensions of everything you've got to house. This was just kind of give you an idea about those running costs that I mentioned. So this is quite a nice slide because it gives you, these figures were updated in July this year. So it gives you a bit of an idea about the current kind of running costs. I've used this slide for a few years now, and I update it quite regularly, and I always find it really interesting to see how the cost of all the different fuels kind of fluctuates. So, you know, oil has been much higher than it is right now, as has LPG, and obviously things are changing all the time. We're all aware of kind of, you know, the fluctuations we've had in our energy bills at home over the last couple of years. But what this really shows is that actually, as I mentioned before, there are not huge savings from a running cost perspective at the moment with kind of air source and ground source in comparison to mains gas, and we're even not that far right now from oil and LPG. But I think it's not just about the running costs, it's about being green, it's about going the right way. And we don't know, you know, moving forwards, I would expect the cost of mains gas to increase as the government's looking for us to move away from that. So it's worth kind of, it's a good slide to demonstrate that you're not going to slash your bills in half, but actually, you know, an efficiently designed system is going to be a cost-effective way of running your house and providing all your domestic hot water. And of course, if you're also integrating things like PV into the system, sort of photovoltaic, you're going to get that electrical kind of benefit towards your running costs of items like your heat pump as well. Just while we're talking about electrics, actually, it's very important to mention that a heat pump is a large electrical item. So you do need to factor in things like getting approval from your distribution network operator on the installation of this. So it's just something to bear in mind if you're kind of thinking about putting one in. You do need to make sure that your electrical supply to the property is going to be up to the job of this type of item going in. The current scheme that's in play is the boiler upgrade scheme. This replaced the renewable heat incentive. It's they've not had the uptake on this that they're expecting so far. So they've just announced they've extended it to 2028, which is great news. It's £5,000 towards the cost of an air source unit and £6,000 towards the cost of a ground source unit. Everything has to be done under the MCS scheme. So that's the microgeneration certification scheme that I've mentioned before that we are a member of. Everything has to be an MCS approved products, which all of our units are. It has to be an MCS approved sort of commissioning and installation side of things, which we can support you on. this is I think the name of it also has made self-builders who are doing like a complete new build think that maybe they're not eligible because it's called a boiler upgrade scheme. But actually this does count for custom builds for self-builders. So you are still eligible for that grant. And we would advise you on that. We do the whole application process. At the moment, 3% of all the boiler upgrade scheme applications that have been done so far have been done by NuHeat. We've got a whole in-house team running that side of things. So we've got it nailed. We've already drawn down over £1 million for our customers and sort of got that redeemed those vouchers and got that money back. So it's working really, really well for us, and we've got it got the process nailed. So always happy to talk to people about that one. This is just kind of a last slide to just give you a bit of a summary really about air source versus ground source. So the average installation costs are going to be quite a bit higher with the ground source because of the cost of getting in those kind of that ground loop array, those install costs. That does push that initial cost up. You do need that large area that I mentioned. So it's worth kind of, like I said, 90% of installs in the UK are air source at the moment. Ground source have their place in the right type of project, but I think that the key thing really, the key takeaway for heat pumps is that they are brilliant. They are absolutely brilliant in the right situation. So a well-designed system is critical. A system that's factored in all of the kind of detail of your project, that's really understood what you need, and what it's running, how it's going to work. They can be a really, really great solution. Always speak to the company that you're looking at with that. And this just kind of finishes everything off really. So that bespoke integrated designs, both on the underfloor heating and the heat pump side of things, gives you the absolute peace of mind. You know, it's your project, it's your forever home. You're going to be kind of living in this house. You want to be confident that system has been designed for your house. It's not just kind of an off-the-shelf pack sort of product or system. That the underfloor heating and the heat pump has been designed as an integrated system if you're going down the renewables route. And that you've got that lifetime technical support really. So whoever you decide to work with on your underfloor heating and heat pump, just make sure that they're really understanding your project and sort of finding out about everything to make sure it's been designed bespoke for you. And I think that's me done.
Brilliant. Thank you, Jo. That was, so much value in that. Thank you very much.
I went on too long. I'm sorry. I tend to do that. I got into it.
No, don't worry at all. And for anybody that would like to have Jo's details, find out a little bit more about NuHeat, or you'd like the presentation, please just pop your email in the chat and I'll send it out to everybody tomorrow, just in case. But we've got a few questions, so I'm going to go through them. Again, any we don't answer, I hope you don't mind, Jo, but I'll share them with you anyway afterwards, and we can send the answers out later this week.
Yeah.
Okay, fab. So the first question from Martin and Sarah, does NuHeat supply a single brand of heat pump, or can we choose the brand and type of air source heat pump to best fit our property?
So NuHeat supply NEBI ground and air source units, and we also supply Panasonic air source units. So we supply certain brands, but we're just as happy to supply underfloor heating to work with somebody else's heat pump, and have done that on lots of occasions. So we can design an underfloor heating system and supply that to run with somebody else's heat pump if you didn't want to use the brands that we supply, or we can quote for a fully integrated system.
Brilliant, thank you. Okay, the next question. So underfloor heating, what experience of putting some just in case underfloor heating into passive house standard builds? We know the theory says that we shouldn't really need any heat over and above towel rails, but when I'm older, I don't want to be cold, and I'm thinking of an insurance in the form of a backup heating solution. If you've done it in passive house builds, what's been the learning? Water versus electric systems, main living areas versus just the smaller bathroom spaces?
Yeah, this one does come up quite a lot actually. And we've certainly supplied underfloor heating system to go into sort of passive house or close to passive house kind of insulation levels. Officially, obviously passive house shouldn't need that heating, like you said. But I totally understand your kind of concerns there. I suppose from a just in case point of view, going back to that control side of things, because you've got individual room thermostats, those rooms are going to recognize, that thermostat's going to recognize if this room is at the temperature it needs to be at, there's not going to be any call for the underfloor heating to run. But you have then got that provision if it did, get particular cold climates, been a bit bonkers over the last few years, hasn't it? But if it does then get, it does get very, very cold and that underfloor heating is then needed, then you've got that provision there if you want it. There's definitely an argument for potentially just going for, sort of electric mat systems. So you've got that little bit of backup. Some people still, even in a passive house, want to be able to take the chill off tiled areas, I think especially is where we have seen it be sort of more of interest. So again, we're happy to kind of look at those as options and certainly have supplied systems to go into that type of property.
Brilliant, thanks Jo. Next question from Martin and Sarah. Is it worth installing MVHR with integrated heat pump without underfloor heating?
So MVHR is a great thing to put in. I mean, and from our point of view, we don't supply it at the moment. We have got sister companies as part of our group that do MVHR. It's just going to make everything more efficient. That's what I always say to customers. So there are some integrated MVHR and heat pump systems that I know are on the market. I'm not an expert in those. I think they tend to be better suited for kind of smaller projects. What we would always say is we would always be designing and sizing the system, whether that's heat pump or the underfloor, to provide all of the space heating without factoring in any supplementary. But if you have then an MVHR system in there, that's just going to make everything more efficient. So it's only going to take some of the pressure off the underfloor heating side of things. As a standalone system, I think it's personal preference really, because obviously if you were just wanting to put in an MVHR system and relying on that for heating, personally, I would recommend having some form of heating, whether that's radiators or underfloor heating, and the MVHR system is there going to just make everything more efficient from a design point of view.
Brilliant, thank you. The next question from Lisa is it better to oversize the heat pump so it can deal with more extreme cold weather, or will this reduce the efficiency during normal weather?
Yeah, I mean, they'll all work. They will all kind of, the way a heat pump works is it should be sized accurately. You don't want it massively oversized, because you're right, then it can affect the efficiency of the unit in kind of normal conditions. I think as I mentioned before, we're always sizing a heat pump to provide over 100%, and we'll be able to tell you exactly what that figure is for your individual project when we look at it, when it's -3 degrees outside. What we tend to do is, when we look at it, it's quite interesting. I've seen some of our design from our sort of design sheets, and when we're looking at sizing a heat pump, when we're checking it all at the design stage, we're actually basing it on exactly where that project is in the UK and looking at the average kind of winter temperature there, as well as kind of this -3 that I mentioned, and then kind of standard MCS requirements. We go above and beyond what MCS is saying we should do as a minimum for the heat pump. So we're actually kind of being more cautious in our sizing side of things, which is why sometimes we do, when people are comparing us to alternatives, NuHeat will come out with a higher size heat pump, but it's because we're making sure that we've covered that sizing as accurately as can. I wouldn't recommend going massively oversized, but I think the way we do it in NuHeat, I'm really confident is a really good option.
Fab. Okay. Tanya's question: in a renovation with traditional radiators, do you just remove the radiators and then use the existing radiator plumbing for the underfloor heating?
No, because the way we're running underfloor heating is slightly different. It will run really happily alongside radiators in other parts of the house. So quite often people want underfloor and the ground floor and radiators upstairs. That's fine, but you want those two systems to run independently to each other. So with underfloor heating, we can't run directly off like a radiator feed, because we actually have to go through a manifold system, which is your distribution point for the underfloor heating pipework. So you have your sort of hot sort of feed to your underfloor heating manifold. Each end of the pipework then goes out from and back to the manifold. So the manifold should be located as centrally as possible to the zones that it's feeding. So typically, if you were doing a whole ground floor, you might have your manifold in a cupboard under the stairs, and each length of pipework is then going out from and back to the manifold, so there's no joints or anything under the floor. So you can't just kind of link on to an existing radiator feed, because we also need to blend the water down to the lower temperature that we need for the underfloor heating. So that's done with the blending valve on the manifold. But yeah, always happy to kind of talk that through. And the design that we'd go through would give you bespoke system design, tubing layout diagrams and everything, showing where everything needed to be sited.
Okay, brilliant. Question from Catherine: will the BUS also be valid for new build projects in Scotland in 2028?
Oh, I don't know that one. I'd have to if you can get that one over to me, Jennifer, I can check with our team and find out if we've got any update on that. So I'd need to check that with our team back in the office.
Yeah, that's fine. I'll send it over. Dan and Kelly, I've got 3 questions. Number 1, how noisy are your air source heat pumps? Are there quiet options? We're concerned about proximity to neighbours or vibrations on external walls.
Okay, so the first thing to say with the vibration side of things, I think, is that they are, as I mentioned when I was talking about them, they're designed to sit outside a domestic dwelling. The case has got like super insulated, and it's got all these layers of like things to kind of prevent that vibration, so you won't get that. The noise that you'll get from a unit is the fan unit running. The NEBA units especially are one of the quietest on the market. They've got what's called owl fin technology, which I always think sounds quite quaint, and the actual kind of fins on the blades of the fans to make them cut through the air as quietly as possible. I don't, off the top of my head, I don't have the exact decibel ratings, but we do have them on all of our kind of info sheets on the different units that we supply, and that's why I mentioned about where you're locating it with proximity to neighbouring sort of properties and what's called their habitable windows. So that doesn't include kitchens and bathrooms, so it does include living spaces and bedrooms, which are classed as habitable rooms. Where that heat pump is, you factor in where you want to locate it, and then the test position is that nearest habitable window. And there are certain distances that need to be factored in to make you kind of pass what's called, it's called MCS 020, and it's kind of a checkpoint that basically needs to make sure that heat pump's going to be okay, it's going to pass that, come under the permitted development. We can advise you on that. I think the best thing to do is to have a look at your project, where your neighbours is. We offer also site visits, so we can always come out and have a look at that with you and advise on that, and talk about location. There are options with air source units as well to locate them remotely from the house, so you can have then a length of pre-insulated pipe. So we do have customers that sometimes want to put them down the end of their garden, and then they'll use a length of pre-insulated pipe to take that pipe work back into the house. So that's an option as well if you didn't want it right by your house.
Brilliant. Okay. And the second part of the question for Dan and Kelly is, do your installation partners ever sell as a full package, including supply, so that we could benefit from reduced rate VAT?
Yes, so certainly some of our installers our registered installer network will kind of work with us. We can put you in touch with them, and they will sometimes come to us for a full kind of package to buy on your behalf, so we can do that. Heat pumps are currently 0 rated on the VAT, because if we're commissioning the unit, which we would tend to be doing, so we would 0 rate the VAT on the heat pump, on the renewable side of things, as part of the system. But the underfloor heating, if you're buying it from us direct, then we do have to charge VAT, because in the eyes of the VAT man, even though it's a bespoke design system, because we're not installing it, then we do have to charge the VAT on the underfloor to self-builders.
Okay. And the third part of the question is, are there any issues with having auxiliary heat sources such as MVHR with a heating element or placement of infrared panels for comfort, etc.?
So as I mentioned, when we're designing a system, we're designing that to provide the full heating load, not factoring in any supplementary heating. So if you put those in, that's absolutely fine. There's no harm in putting in there's no harm in putting in MVHR. That's just going to make everything more efficient. Infrared heaters as well. You can have them as a little bit of a boost. They're not going to affect us. What you can't put in is like a gas fire. If you were having to be eligible for the boiler upgrade scheme, you can't have any kind of fossil fuel heating. So you couldn't have a gas fire. But you can certainly, MVHR's great thing to go for. And I put in infrared is also, I think people people that put them in as a little boost in rooms as well. But we can always advise you on that, depending on what you're looking at doing and whether it's going to pass the requirements for the scheme and things.
Okay, great, thank you. And I know that we have hit 8 o'clock, so there's a final question. I know there's lots of other ones I haven't got to, but I will speak to Jo tomorrow and we'll get some responses sorted for the questions and send them out to everybody.
Sorry, that's me waffling on too much. Sorry, everybody.
Okay.
losing you all for a few minutes as well.
Mark, I think you've got a question about installation costs. Please do come off mute.
I'm going to surprise you and be Catherine, not Mark. Hello.
Oh, hi.
It's all right, Catherine. I'm being David.
It's the second section of the evening. This is probably a numpty question, but you suggested that installation costs were between 10,000 and 15,000. Is that installation costs including all the materials, or are there additional costs to think of on top of that?
No, that should cover the kind of an installed system. So that's a rough guide for an installed heat pump system. So as I said, we're design and supply, so we're not including the installation costs in our quotations. So, but those rough guidance figures will be including the physical install side of it as well.
Cool. Thank you very much. That was our question.
You're very welcome.
Brilliant. Thank you so much, Jo. You've given a lot of information, so really appreciate that. And for anybody that's looking to join Build Manager and get a little bit more support in your self-build journey, you've got our QR code there, so you can have a look at the offerings. But yeah, that was a fantastic evening. Massive thanks to Jo again, and I hope everyone enjoyed it.